Hello and welcome to this tutorial. We are continuing the series of Spark plus PySpark. Today we are going to discuss about cache and persistence. Cache and persistence both are optimization techniques used to improve the performance of Spark jobs. Using cache and persist methods, we can save the intermediate Spark computations of RDD or data frame so that these computations can be reused in subsequent actions. Catching and persisting of Spark data frame is a lazy evaluation, meaning a data frame will not be triggered until you trigger an action. So they both are optimization technique that are going to be used to improve the performance of Spark job. And using both these methods, we can save the intermediate computations of RDD or data frame if we want to reuse them later. Let's come into a real-time example. We are reading a CSV file in Spark using the function spark.read with header equals to true, and we are giving the path of file here. Once we read this data frame df, we are going to perform some transformations on this data frame. So what we are doing, we are creating a new data frame named as df2, and we are going to join df with one another data frame df1. This is how data frame 2 or df2 has been created. Now we are going to perform some transformation on this df2. So we will create data frame 3 named as df3. We will join df with df2 to create df3. So we performed inner join to make df3. We performed inner join to make df2. So df, df2 and df3 has been created, and all these three are going to be immutable. Means once we create these, we cannot write anything on these data frame. Once process moves forward, in our case, all the data frame variables will be emptied inside executor, and dfs will be in short-lived memory once action is called. So till the time we are not calling any action, these transformations will be inside executor, and once the action will be called, these data frame variables are going to be transferred to short-lived memory. Seems once we call the action, once this process starts, automatically these data frames will be lost as computation move forward. So whatever we created as df, df2 and df3 as in some intermediate computations, they are going to be lost once action is going to be called. But if we need these data frames later in the computation, in such scenario, Spark will go back to the line where line was creating that data frame, and Spark will recalculate that data frame. How can we avoid this recalculation? We can avoid this recalculation using cache and persist method. See how we are going to avoid this recalculation. So what we will do now, we will read this data frame as it is, but what will we add? We will add one dot cache function while reading this CSV file. What this catch function will do, this catch function will now put this data frame into the memory executor instead of short-lived memory. So once action is going to be called, this particular data frame is not going to be in the short-lived memory. Instead, it is going to be in memory executor. This data frame will be alive till application runs. So this is how cache function is solving our problem so that we can reuse these intermediate calculations later in the application. Moving forward, we are going to discuss about cache storage levels. So we are supposing one condition. Let's suppose we have data of 2 GB and it has 15 partitions in it, but in memory executor pool we have 12 partitions. In this scenario, these 12 partitions are going to be saved into memory and rest 3 partitions are going to be saved in disk. Why it is going to happen? Because by default usually caching happens in memory only, but if partitions are not getting fit in memory executor pool, then rest partitions will be saved on disk, so it will take memory and disk options. So cache will have two options. One will be memory only, that is going to be default. If partitions are not getting fit into the memory executor pool, in that scenario we are going to save rest partitions into the disk. So in that scenario we are going to pick second option, that will be memory and disk. Persist is also going to do the same thing. It is also going to save us to recalculate the calculations that we did in our code, but it has some more flexibility as compared to cache function when it comes to storage levels, because it has some additional storage levels available in it. It has one option as memory only, that is going to be default. Second option is memory and disk. Third option is memory only serialized. Let's see how they work. In memory only, we all know all the partitions are going to be stored in the memory in the deserialized form. In memory and disk, data will be first stored in memory, then the left data will be stored in disk. Here, disk data will be in serialized form, while memory data will be in deserialized form. And CPU will be highly used to deserialize data which is on disk. This is why it is timely process. Now we have third option where data will be stored in memory in serialized form. In serialized form, we can store more data as compared to deserialized form. Here CPU utilization will be high because data will be serialized for further processing. Next option is memory and disk serialized. This storage level is similar to memory only serialization, but it drops the partition to the disk if that does not fit into memory. Here in both places data will be stored in serialized form. Disk only. Data will be stored on disk in serialized form. It will be a slower process. Here nothing will be in the deserialized form. Everything is going to be stored in disk in serialized form.